All right, good afternoon, everybody. Thank you for being present for this afternoon's webinar. So we are very fortunate to get Ms. Jennifer Low and Mr. Halil Shaiful from State, and Jennifer is from Lum Chang. So they will talk about IDD, and this session will be recorded. So each session is about 30 minutes. And you are free to ask them any questions at the end of the session, right? So I will just now invite Jennifer to begin the session first. Jennifer?
Sure. Okay, let me share my slides.
Mm-hmm.
Can you see my slides?
Yes, I can.
Okay. All right, good afternoon, everyone. I'm Jennifer Low, Senior Digital Manager of Lum Chang Building Contractors. My presentation this afternoon is on Lum Chang's digital transformation with IBD. Just give me a minute. My presentation will consist of 4 parts, starting with a short introduction of Lum Chang, followed by what is IDD and our IDD adoption, and finally a summary. So founded in the 1940s with a legacy of more than 7 decades, today Lum Chang Building Contractors is one of Singapore's leading local builder, providing fully integrated service in the construction industry. Our portfolio covers from building projects to civil and infrastructure projects. So how did Lum Chang transform with the IDD adoption? Besides achieving technological capabilities, we were able to also improve our sustainability, our environmental, health and safety, strengthened our competency in building projects, advance our capabilities in complex civil and infrastructure projects, and building capabilities for the workforce of the future. Virtual Design and Construction, or VDC, is an integrated approach that combines the use of building information and modeling, which is BIM, and advanced management methods to simulate the complexity of the construction project delivery. So the value proposition is to understand the difficulties the project team is likely to encounter, to analyze these difficulties and address them in a virtual world before any of the construction work ever takes place in the real world. So integrated digital delivery, which is IDD, aims to connect all the project stakeholders through the digital information. Such shared information creates through BIM VDC will allow the integration of the entire project delivery process from design, fabrication in factories, assembly on site, to operation and maintenance of building. Some of the tools and methodology of IDD technologies and innovation that has played a fundamental part in our transformation, they are outlined here, and they span between all the 4 core sections of IDD. I will briefly touch on each of them. In digital design, in cross-phase integration, the design BIM model are usually handed over to or procured by the main contractor upon award of contract for the development of the design model to construction model. What you see here is a federated construction model with all the different disciplines for design coordination. The next example shown here is the federated model of an infrastructure road tunnel project. Usually 3D modeling is only applied for permanent works. However, considering that a large part of this project are interfacing with existing utilities, we have decided to implement 3D modeling for the entire project, including all the temporary works for ERSS design and coordination. Selecting the best software for its purpose, the 3D models were developed using multiple softwares to improve productivity, design analysis, and coordination. Computational BIM software such as Rhino was used and integrated with Bentley Open Building to optimize the design and develop the alignment of the tunnel structure. Tekla was used for steel struts and traffic deck model, and the rest of the models were developed in Revit. The temporary works model was also used for generation of ERSS shop drawing. The development of 4D scheduling provided visualization for all the stakeholders of the project, assisting in cross-disciplinary, cross-trade, and cross-phase integration effectively. In complex civil construction work, 4D sequencing on critical parts of a project is used for visualization and discussion during technical meetings. However, the lower right model you see is actually the 3D coordination of an existing MRT pier and the new transfer beam with rebar to ensure that the rebar does not clash with the existing vehicle piles. For public works that affect the wider community, it is common for the contractor to brief the grassroots leader of work site for their support on the works that might potentially has an impact on the daily life of residents within the community. The project team actually implemented 4D animation video to improve visualization of the critical upcoming works that require us to brief the stakeholders. So the feedback from the stakeholders on this new technology was that it was very clear and easy to understand. 5D cost model. The 5D cost model allows us to utilize the 3D model to improve productivity in cost management by having an integrated workflow from 3D modeling to quantity takeoff to payment. Here you see how our subcontractor Pajama, they were using computational beam in Grasshopper to develop an MRT viaduct in Tekla. Not only were the design of the viaduct optimized, the rebar within the viaducts were also optimized using computational beam. In digital manufacturing and fabrication, the nature of precast concrete construction entails true pre-construction planning. As various aspects and phases of a project are interrelated, the success will depend largely on how effective the linkage between each construction phase during implementation. Construction sequence, production scheduling, resources are therefore important and need to be closely monitored to avoid costly delay in site progress. Trimble Connect system utilizes a 3D precast model that is imported into their system and identify and track the status of each precast component using either the barcode or the QR code at 5 stages. So the first stage is casting, second, quality control, third, leaving the factory, fourth, arriving on site, and fifth, installation. So each time a precast component completes one of the stages, the barcode or the QR code of the component will be scanned and the status will be updated in real time on the 3D model in Trimble Connect system. This allows the project team to track the precast component progress in real time from their desk. Similarly, defective component that is rejected will also be scanned and updated in the system in real time so that the factory will realize it immediately. Next is actually a video of the whole process that I've just explained. So it starts with tagging. In the factory, in the precast factory, they will use the 3D model and generate the detailed drawings, create a unique ID, has it printed out. Next is the manufacturing and quality control. So our team will be on site to do inspection, periodic inspection. This is the tagging that's ready for delivery. So they'll scan it with the barcode. Coming from Malaysia. So the reason why we had barcode and also QR code is because in Malaysia they are using the barcode, whereas in Singapore we prefer to use our QR code. So we have both integrated into the tag. So once it's arrived, it'll be scanned. And you can see from the top right hand corner, you'll see it will change in real time when the item is scanned. It will change a different color that says that it has been delivered, which is in green. So as we look into improving productivity during construction, the use of prefabricated bathroom units, or PBU, when possible, is a good option. We have completed a mixed project development project in which we use Singapore fabricated PBU. So the design timeline took approximately 7 to 8 months, including studying and coordinating with the fabricator. It is a 5-sided PBU and the size is 2.2 meters by 1.8 meters wide and 2.725 meters height. So the height of the PBUs were critical as it affected the delivery. So you can see in the table here, we have 2.725 meters PBU plus 650 M&E services below, plus a 1.05 meter low bed delivery vehicle. The overall transport height for the PBU is now 4.450, which is 50 mm below the allowable height of 4.5 meters for public road. Hence, M&E services had to be compressed within the 650 mm. Also, when studying the design, we had to take into consideration the details of the finishing as it has to withstand dynamic movement caused by transportation and hoisting work. For Design for Manufacturing and Assembly, or DFMA, for mechanical and electrical works, we utilize this as one of our light industrial projects for all the M&E services running along the corridor. So the design timeline with the specialist took about 4 months, and each M&E module was 6 meters length by 1 meter width and 2 meters height. The benefits are for better quality, safety, and also improved productivity, as traditionally each trade had to be installed individually. With the module system of all the coordination is done upfront, and also abortive work is reduced. So this video will show you, take you from fabrication to installation. So in the offsite factory, you have a factory layout that shows the production workflow, the production office area, material storage, and how they do the material cutting and setting up of the main frame. And then after that, they will have quality control checks. after which this module is loaded and transport to site for installation. Due to the size, it will be lifted, and using scissors lift, we will actually install the module, and then they will be connected on site. So this actually takes, give us a lot more productivity. For rebar fabrication, we have established a full process of rebar modeling, rebar shop drawing production, extracting the BBS or bar bending schedule from the Revit model, procuring the rebar from the fabricator based on this rebar BBS. So how it works is that by using the Revit template from the rebar fabricator BRC, errors are checked as we model the rebar in the Revit template. Errors are checked and resolved within the Revit software so that the BBS exported are free of errors and can be imported directly into CNC for fabrication. So this integration and the direct process improve our overall rebar documentation and also productivity in rebar procurement. To improve the steel structure construction methodology for steel building, we use cast-in nuts in columns for connecting structural steel beam to RC column and core walls. This accurate positioning of the cast-in nuts is possible with the use of 3D model. Correspondingly, the safety team also uses the 3D model to visualize and identify steel beams that require temporary steel safety barricades from the 3D model. So the temporary steel safety steel barricades is designed in the 3D model and fabricated together with the steel beam. This will improve productivity in temporary steel barricade installation. In digital construction, the project collaboration platform provided a secure and robust cloud-based communication platform between project users. It improves and enables traceability, compliance, standardize the documentation management for the entire project lifecycle. The platform covers drawing management, document management, model sharing, and also digital collaboration. So full integration within the project value chain is achieved with using such collaboration platform. So these are 3 collaboration platforms that we have used to date. We also have collaboration platform for model and also safety platform. Supporting beam to field communication and visualization on site, the collaboration platform also allowed the project team the ability to view 2D or 3D models without the need for native software on a tablet. This enabled the project team to bring real-time digital data on site for inspection. This also improves our sustainability as the need for printing drawing is no longer required. With weekly drone flight, the project team were able to obtain and review aerial view photos and videos of the site progress in the office. Using the same weekly drone footage, the safety team was able to review the project from a bird's eye view and identify concerns that would be impossible to see at ground level inspection. This will also improve our risk management significantly. So we also have implemented virtual reality safety training for the project workers. This technology is not meant to replace conventional hands-on training or instruction by in-person trainer, but rather it was commissioned as a beneficial tool used to supplement traditional form of training. So this VR safety training provided the opportunities for workers to practice safety procedures and processes in familiar environment through immersive technology. So for example, we commissioned an external vendor to produce 4 interactive scenarios similar to real life situations. So we have traffic management, lifting operation, also work from height, and also healthy living. So the Immersive training included simulating the way personal protective equipment works and how it should be used. Complex situation and processes were also created through VR, allowing the workers to practice the situation in a simulated environment. So for example, the workers were able to practice lifting work or work at height without risk of injury. Additionally, the VR also provided an opportunity to enhance training, adding value to the employee's experience and also improving an employer's ability to reinforce key safety points. In digital asset delivery, to provide useful information about the building for future maintenance or retrofitting, we utilize COBE for asset data input. This relevant information exported from Revit can also be populated into various facility management systems. So what you see here is by clicking on a Navisworks model that is linked and embedded with all this information. By clicking on the link, it will put out all the documentation. We adopted the use of laser scanning for two of our projects that has interfacing with existing building. So this tool is especially useful for existing building where the aspect drawing are generally not in good condition. So this is a scan of a Tanah Merah MRT station. Using the 3D model, the robotic total station allows us to verify the virtual and the actual geo coordinates of the constructed work, especially when we had a lot of SBP for one of our infrastructure projects. We use Dynamo to extract all the geo reference and also check them with our robotic total station on site. So in summary, as we work towards digital transformation, there are a lot of different softwares, tools, and also technologies available. The important part is to know which is best for your project. Only by selecting the most appropriate software, tools, or technology, you'll be able to increase your productivity and also improve your sustainability. Thank you.
Thank you, Jennifer.
Thank you.
Thanks for the sharing of your the IDD portion. Would there be any questions from the participants? Please feel free to ask Jennifer any questions regarding her presentation, or otherwise you can also ask at the end of the next session as well. Or you can type in the meeting chat if you're too shy to ask.
Hello. Punita, may I ask my questions?
Yes, please, Dr. Teo.
Oh yeah, just want to ask Jennifer. I think it's quite exciting to see that this has been implemented in Lum Chang. So just curious that how many projects this IDD process have been implemented by Lum Chang, or only a selective one?
No, actually since 2011, we have implemented, we started with BIM modeling, and then since then, all our project is in the BIM, VDC, and IDD. So whether or not it is specified in the contracts, we will do selecting whatever that is the best available tools and softwares that we need to use. So it's actually across the board. Even like, for example, like earlier on, I showed a infrastructure project. So in the contracts, it's only permanent works that is required to have BIM modeling, but we have done the entire, including all the temporary works in BIM. Because we understand that that will be actually very useful for us.
Okay, having said that, I think the follow-up question is if you are doing this, I suppose your team will have to get involved in the tender stage. When is your team that coming in to get this framework set up together so that you know, all the requirement by the subcontractor, everything, they can follow your standard.
Correct. So actually at Tender, we already start doing our BIM modeling. Of course, it will be a different set of criteria. Once we are awarded with the contract, we will have a team in place and standard in place that we will work together with our subcontractors, and we will work within usually for a lot of these projects, we have the first 2 to 3 months to really push and build it up.
Okay, so I understand the first 3 months is very important, but is
Yes.
it a criteria for you to select your subcontractor as well? So they must follow.
Well, we do select. I mean, it's something that we would hope that whichever subcontractor we're working with, that it'll be good if they have the capabilities, but if they don't, then we work with them to build their capabilities. So a lot of times we have been giving training to our subcontractors as well.
Yep, thank you very much. I think it's quite, looks like you are quite successful in implementing this.
Thank you.
Very happy to see it. If nobody else asks question, maybe ask another one. So what is the typical problem that your team is facing?
The typical problem is, I would say that the interfacing between all the different departments. For example, we are trying to, as we do 3D modeling, we want to go into cost model. We want to go into with our operation team for fabrication and everything. So getting our BIM team to work with our QS, with our operation, all these entitled, you need a lot of integration. So that is actually one of the challenges that we actually have, more than just the tools on the technology. It's the interfacing between different groups of people.
About the access right, do you face any issue when it comes to access right, because some information are actually sensitive, for example cost information, and then sometimes do you allow subcontractor to access certain of your informations?
Well, no, the cost model is actually used by our QS to do quantity takeoff, and also they will push out. When we push out on cost X, there are certain criteria that we can close up that doesn't go out of the office. There's access to that. We can adjust it. So in terms of sharing with our subcontractors, no, there's no sensitive information that we are not able to manage. Yeah.
Okay, thank you very much.
Thank you.
Any other questions from the floor? Okay, there have been questions on whether the recording will be made known. Yes, we will publish a recording in a YouTube form. That will be, maybe you can check back later tomorrow at 2 websites. Okay, one is the computational.space and the other one is the IBDC 2021 website. All right. So yeah. Okay. Any other questions from anyone for Jennifer? We have a good turnout today. We have about 70 over people attending this, which is very encouraging. Okay, so maybe if let's say you do have any questions for Jennifer, you might want to either type in the meeting chat, or maybe you can ask her at the end of the after Halil has shared his sharing. Okay, thanks Jennifer. Thank you.
you.
All right.